Welcome back to Pod 4 Journal Club. Okay, I want you to imagine something. What if you could create a single, massive piece of art, but it's made of thousands of tiny, unique images, none of which were ever real photos to begin with? It sounds like science fiction, right? Well, today we're diving into some incredible new research that does exactly that, completely reinventing a classic art form, the photomosaic, with some seriously powerful AI. Just look at this. I mean, from a distance, you see one big, beautiful, coherent picture. But as you get closer, you realize it's actually made up of hundreds, even thousands, of smaller, totally unique images, each one telling its own little story. That's the magic of a photomosaic. And here is where things get really wild. Usually, to build something like this, you'd need a gigantic library of actual photographs. But this new research asks a different question. What if you didn't need any real photos at all? What if you could just create every single tile from scratch, making it a perfect fit for the bigger picture? So here's our roadmap for today. First, we'll talk about what it means to reinvent the photomosaic. Then, we'll get into the nitty-gritty of how this AI actually works. After that, we'll look at the jaw-dropping results. We're also going to talk about what it can't do yet, the gaps. And finally, we'll zoom out to what this all means for the future of art. All right, let's kick things off with how this whole approach totally flips the idea of a photomosaic on its head. This is all about a massive shift, from simply searching for existing images to actually creating brand new ones. Okay, so let's just make sure we're all on the same page. A photomosaic, right? It's one big picture, the reference image, that's built from tons of tiny little pictures or tiles. You stand back, you see the forest. You get close, you see all the individual trees. Simple enough. And wow, this one image shows you everything you need to know. On the left, that's your classic photomosaic. See how it's kind of blurry, a little repetitive? It's just working with what it can find. But now look at the right. That's the new generative method. The big picture is so much sharper, and every single little tile is crisp, detailed, and unique. It's a night and day difference. The old way just had some big problems. You needed these colossal photo libraries to even try. And the whole process was basically just a fancy game of color matching, which is why you got those blurry results, with the same photos popping up over and over again. The bottom line? It was a process of finding the least bad fit, not truly creating something new and beautiful. So if the old way was kind of broken, how on earth does this new AI method work its magic? Well, that brings us right to our next section, how this AI actually generates the art. This is where the cool stuff happens. So, the engine behind all of this is something called a diffusion model. The easiest way to think about it is imagine the AI starts with a screen full of pure static, just random noise. Then it learns how to slowly, step by step, remove that noise until a clear picture appears. It really is like a sculptor who sees a statue inside a block of marble and just starts chipping away everything that isn't the statue. And this is the absolute game changer. Instead of digging through a database for a photo that's, kind of bluish for a patch of sky, the AI just synthesizes a brand new, absolutely perfect image for that exact spot. It's custom creation, on demand for thousands of images at once. The way they pull this off is super smart. They call it the frequency-aware method. Think of it like this. First, the AI looks at what they call low-frequency data. That's just the blurry, big picture stuff, the overall shapes and colors. Then, it generates new tiles that match that general vibe. After that, it fills in those tiles with high-frequency details, all the sharp, interesting textures, based on a prompt you give it, like underwater sea creatures. This is a perfect way to visualize it. On the left, that's the low-frequency structure. It's the blurry ghost of the final image. The AI's first job is to make sure the final mosaic looks like that. On the right, those are the high-frequency details, the sharp, unique, interesting little pictures that will actually become the tiles. The genius of this whole thing is how it perfectly blends the two. The authors of the paper put it perfectly. They say, their work changes photomosaic creation from a combinatorial process to a generative one. In plain English, it's not about finding and arranging old puzzle pieces anymore. It's about creating brand new art from scratch. Okay, the theory is cool, but does it actually work? What do the results look like? Let's dive into part 3, the stunning visual results. Because with art, you really have to see it to believe it. Check out this comparison. On the left, you've got a mosaic made with a traditional method. It's fine, a little pixelated, kind of hard to make out the details. But then, look to the right. That's the new generative method. I mean, the difference is just incredible. The overall shape is crystal clear, the colors pop, and you can see that every single tile is a unique little piece of art. So, how does it compare to other new AI tools? On the left is another AI approach, and on the right is our method from the paper. And what you'll notice is that while other AIs can make pretty tiles, this new generative method is just so much better at keeping the overall structure, the big picture, looking solid and recognizable. Now, the researchers didn't just trust their own gut, they actually ran a user study. And the numbers here are really telling. Look at that first row. Compared to the classic technique, people preferred the new method's overall structure a whopping 98.7% of the time. But look at that last row. For the tiny details on each tile, another AI was actually preferred. That's super interesting, and we're going to come back to it. Just let that number sink in for a second. 98.7%. When it comes to the single most important job of a photomosaic, making sure you can see the big picture, this new technique is basically a slam dunk. It's a huge, huge step forward. But you know, good science isn't just about showing off your wins. It's also about being honest about where you can still improve. And that brings us to our fourth section, acknowledging the gaps. So this really gets to the heart of the trade-off we saw in that user data. The absolute undeniable strength of this method is its global coherence, making the big picture look amazing. But the area where there's room to grow is in the local detail. Like we saw, some people thought another AI made slightly prettier individual tiles, even if the overall mosaic wasn't as good. And that right there sets up the big challenge for everyone working on this stuff next. How do you get the best of both worlds? How do you create a mosaic that has a flawless, big picture and where every one of the thousands of tiny tiles is a little masterpiece? That's the puzzle to solve. All right, for our last section, let's zoom all the way out. Let's talk about the AI-powered future of art and why any of this actually matters beyond just being a cool tech demo. The potential uses here are just mind-blowing. Think about it. You could create a portrait of a family trip made from tiny AI images of all the things you saw. A company could make its logo out of thousands of pictures of its employees. Artists could create really powerful work by contrasting a bug image with what the tiny tiles are made of. This isn't just a tool, it's a whole new canvas for storytelling. So that leaves me with one final question for you. If you could take any memory you have, a person, a place, a feeling, and turn it into one of these incredible generative mosaics, what would it be? What story would your thousands of tiny images tell? I'd love to hear your ideas in the comments. Thanks so much for joining us at the Journal.